L'Hopital's rule is a very useful tool for evaluating certain limits. I'll break this video down into two parts for the two different cases when you can use L'Hopital's rule. The first case is when you find the limit of a function where both the numerator and the denominator approach zero. Let's call the numerator of the fraction f of x and the denominator g of x. Let's say that we want to find the limit of f of x divided by g of x as x approaches some value a. We can use L'Hopital's rule if the value of the function f of x approaches 0 as x approaches a, and the value of the function g of x approaches 0 as x approaches a. Now in this case, we can't just plug in the value of the functions f and g because we would get 0 over 0. Instead, let's analyze the limit graphically. Here is an example of what the graphs of f and g could look like. You can see that at x equals a, both f and g are 0. Since we are interested in the limit as x approaches a, let's zoom into the x values close to a. If we zoom in far enough, the functions f and g begin to look like lines and stop curving. The slope of these lines is just the derivatives of the function at x equals a. So the slope of the blue line is just f prime of a, and the slope of the red line is just g prime of a. If we want to find the ratio of the lines a little to the right of a, then we can just find the ratio of the slopes, because if the blue slope is 2 times as big as the red slope, then the blue line will have gone up 2 times as much as the red line during the same change in x. Since both lines start at 0 at x equals a, the ratio between them after a little change in x is just how much they have gone up, which is proportional to their slope. Therefore, we can say that the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f prime of x over g prime of x if f of a and g of a equals 0. The second case when we can use L'Hopital's rule is when both the functions f and g approach infinity. In this case, when we divide f and g by each other, we are finding the ratio between their sizes of infinity. So if f over g approaches 2 and g approaches infinity, then f would have to approach an infinity that is twice as big as g's infinity. This means f would also have to be increasing or decreasing twice as fast as g increases or decreases when it approaches a. Therefore, if f and g approach infinity, the ratio between f and g is going to be the same as the ratio between the rate at which f approaches infinity, f prime of x, and the rate at which g approaches infinity, g prime of x. So we can write the limit as x approaches a of f of x over g of x as the limit as x approaches a of f prime of x over g prime of x if the limit as x approaches a of f of x and of g of x equals infinity or negative infinity.